Hello and welcome to this video for Chemistry 20. This is Miss Simpson. In this video, we are going to look at something called qualitative analysis and talk about how that's different from something that we have done in the past, which was called quantitative analysis. So qualitative analysis, think of the word in that, the key in that word, which is quality. We are trying to identify what is present in the solution, whereas quantitative analysis, think of the keyword there, quantity, was looking at the amount of substance present in your solution. Okay, so qualitative analysis is identifying what type of substance is in your solution. Now, there are advanced technologies, something called an atomic absorption spectrum, that can be used in a laboratory setting in like a university, somewhere that has obviously a lot of money to have something like that. But we do different wet techniques. I do a lab with my Chem 20s and actually also sometimes with my Science 10s where we classify solutions. We use conductivity to test what type of solution we have because we know that a soluble ionic compound and an acid will conduct electricity. We also use litmus tests. Litmus paper comes in two different colors, red and blue. If both pieces of litmus paper are red, you have an acid. If both pieces of litmus paper are blue, you have a base. We also test for flammability and also neutral, by the way. If something is not an acid and not a base, it's going to be neutral. And then the litmus paper, both pieces stay their original color. So the red stays red and the blue stays blue. And that's a neutral solution. Acids, again, remember, are identified that they start with hydrogen and they've been dissolved in water. And a base is an ionic compound that has the hydroxide ions in them also being dissolved in water. These are solutions again, right? We also test for flammability because alcohols are molecular compounds such as C2H5OH that has OH in it. Now, it's not the OH ion like it would be in an ionic compound. It's called the hydroxyl functional group. And this is what makes up an alcohol. And alcohols, when dissolved in water, as long as their concentration is greater than 50%, will be flammable. So the lab that I do with my students is getting them to match different solutions to the different tests to identify what solution is in each bottle. Now, other wet techniques that we can use that we'll talk about today are ion colors. Different ion colors or different ions in solution can have colors. Okay? Not all ions in the world have colors, and group 1 and group 2 ions are always colorless, but other ions, some of them are shown on the back of your data booklets. For the students that I have in my class, if you're using the Alberta Chem 30 data booklet, this information is in there as well. But for the ones that I use with my Chem 20s, I have a data booklet, and on the back there is the selected ions in aqueous solutions. So things like nickel 2+. Nickel 2+ is a greenish blue-green color. Fe3+ is an orange-yellow. Copper 2+, we do a lab making a copper sulfate pentahydrate solution. That solution is blue because of the copper ions, okay? Now, if you have a solution with ions and it's not on this list, it doesn't mean the ions are colorless. The list just shows some ions, okay? So you can't for sure say they're colorless unless they're a group 1 or 2 ion, but common ones that have colors are on the list. You have to be careful now also because while iron 3+ has a color of orange yellow, iron 2+ has a color of lime green. So when you have an ionic compound, you need to check which iron ion do you have in that compound. Same with copper. Copper 1+ has a different color than copper 2+. Copper 1+ is blue-green, not the darker blue that you see with a copper 2+. Okay? Next, flame tests. Different metals give off colors when they are lit on fire. Now, why does that happen? The heat from the flame is going to excite the electrons so that they jump from their original energy level, think of the atomic structure, to a higher energy level. When the electrons then return to their original level, they emit visible light. And depending on the wavelength of the visible light, it corresponds to different colors. Flame colors are also for my Chem 20 students on the back of their data booklets. Things like barium is a yellowish green, calcium is a yellowish red, cesium is violet, and so on. Okay? So we can also, if we have an ionic compound that contains those metals, we can test them with flames, and if they burn a specific color, that can help us try to identify what metal ion could be in that compound. The last test that we have is something called a precipitation reaction. A precipitate is a solid product that gets formed when you start with two clear solutions. You mix them together. If it all of a sudden turns cloudy, that means a solid product or a precipitate was formed. So the way this works is you're going to have a solution with two possible ions in it. You're going to add a known solution to that unknown solution to see if a precipitate forms. You're going to pick a solution that has an ion that will form a precipitate with one of the possible ions in the solution and not the other one, so that if it turns cloudy and forms a precipitate, we know which ion was in there. So here's an example. You have a solution that contains either aluminum ions or barium ions, okay? So I have either aluminum ions in my solution or barium ions in my solution. Now you could actually be told that you have the following compound, aluminum nitrate, because ions are never going to be found on their own. Ions always come from a soluble ionic compound dissociating in water. So we start with an ionic compound. When that ionic compound is placed in water, then it will dissociate into its ions. So this will dissociate into aluminum nitrate, and this will dissociate into barium nitrate. Now, both of these solutions have nitrate in them, so that's not how we're going to test between them. One of them has a source of aluminum ions, and one of them is a source of barium ions, okay? So if you're given whole compounds, look at what's different between them, all right? So again, one has aluminum and one has barium. I'm going to add, like I said, a third solution that is going to form a precipitate with one of these ions and not the other. Because these are cations, in order to form a precipitate, it would need to form a solid ionic compound. So I need to add an anion that will be solid with one and not the other. So you basically go through your solubility chart process of elimination, and there's a couple of answers you could have here. I could add sulfate ions to this unknown solution, because how these two ions react with sulfate are different. When the aluminum bonds to the sulfates, and remember they wouldn't technically bond together to form a compound because they would still be dissociated, but I'm just writing their formula to show that this is a soluble compound. Okay, so this is going to keep the solution clear, because remember again, to start, the solution was clear. However, if barium was present in the solution, the barium would, like magnet, stick to the compound and make a solid product, making the solution turn cloudy. So by adding a source of sulfate ions, if the solution turns cloudy, we knew barium was present, because barium and sulfate make a precipitate. If the solution remains clear, we know aluminum ions were present instead, because they stay dissolved, and technically they would stay dissociated. I wrote it as a whole compound, but they would technically still stay as free-floating ions. Okay? Now, the thing is, I said you have to add a source of sulfate ions, and remember, ions never come by themselves. So I'm going to add a compound such as sodium sulfate or potassium sulfate that is a source of those sulfate ions for me. Okay? I'm always going to bond my ion that I'm adding to both solutions to a group 1 ion like sodium or potassium, because they will not interfere with the solubility and cause to precipitate somewhere else. They're soluble with everything, okay? So when you say your answer is sulfate, it's technically coming from a compound such as sodium sulfate or potassium sulfate, which is a source of the sulfate ions. Another ion that could have worked for this was fluoride. So you could have said, I'm going to add sodium fluoride or potassium fluoride, for example. Again, sources of fluoride ions, because when aluminum and fluoride come in contact, they stay aqueous ions and keep the solution clear. But if barium was present, barium fluoride would again cause a precipitate to form and make the solution turn cloudy. Now, in the workbook that I give my students, I have some questions that I'm just going to go over just to show you again what type of questions you're going to see with this qualitative analysis. So you're asked to identify each of the following ions based on the information given. A transition metal has a blue color in solution and a blue flame color. So a transition metal is something in the middle of the periodic table. It's not group 1 or 2 metals. It's the ones in the middle. It has to have a blue color in solution and a blue flame color. So if you check those charts, the solution chart and the flame color chart, you will see that it is copper, okay? Technically, it would be copper 2+ ions, but I would accept copper as an answer as well. Next, we have 2 solutions, and it's asking how could you tell the difference between them by looking at them. So what's different about these 2 solutions? They both have chloride ions, but one is a source of iron 3+ ions, and the other is a source of iron 2+ ions, right? That's what's balancing with the chlorides. So iron 3+ is going to be an orange-yellow color, whereas iron 2+ is a lime green color, okay? And then last, precipitate again. So what's different between these 2 compounds? They both have nitrate. One of them is a source of magnesium ions. The other is a source of calcium ions. It's asking you to distinguish between them by using the precipitation method. So again, we're trying to find something that would be solid with one and not the other. Solid with magnesium or calcium and not the other. One ion that would work, again, just like the previous example, is SO4. I'm going to write this below so that I can show what's happening again here. If I add sulfate ions and magnesium are soluble, okay? So if I were to write it as a whole compound, again, even though it wouldn't be because the ions would still be free, it will remain an aqueous clear solution. But if calcium ions are present, calcium is insoluble with sulfate. I'm checking the solubility chart. This is insoluble. So if the solution remains clear, magnesium was present. If the solution turns cloudy, that means a precipitate solid product was formed. That means calcium ions were present because calcium with sulfate makes a solid, insoluble compound, turning the clear solution that you started with cloudy. Okay, if magnesium was present, the solution remains clear because it's always starting clear. Solutions are clear, right? That's the definition of a solution, is that it is clear. Clear also, by the way, does not mean colorless. If it doesn't have a color, we say it's colorless. Clear means it's transparent or not. Okay, and that's it for this lesson. Thank you for watching.